Welcome to lesson 88. Today we're going to talk about a review of proportional and non-proportional relationships. We've been dealing with proportions for a long time now, and we're going to kind of sum it all up here. So first off, in a proportional relationship, there are how many variables? Well, the answer to that is that there are two variables, an x and a y, an input and an output. Okay, like y equals kx. The graph of the relationship, of a proportional relationship, that is what shape? And the graph of a proportional relationship is a line. And we've seen that. Okay, and when one variable is 0, what number is the other variable? I'm sorry. When one variable is 0, what's the value of the other variable? And that is also going to be 0, because we know that that straight line relationship of those two variables goes right through the origin when x is 0, y is 0, if they are proportional. Okay, an equation in the form y equals kx indicates, it's pretty important, that's a proportional relationship, indicates a direct proportion. As x changes by 1, y changes by a constant factor k. Which of these equations indicates a direct proportion? And we should be able to look at these, and right off the bat on A, we see that 5 is being added to x. That makes it not a proportional relationship. On B, P equals 4 times S. 4, that's that constant of variation. So P is always 4 times whatever S is. That is a direct proportion. And what about C? A equals B times H. It looks very similar, but the problem is B is not constant. 4 is constant on option B, but this lowercase b here on option C, that's a variable. It's changing. It's not constant. So that makes it not a direct proportion. So B is, but C is not, because B is not constant. Okay, as we go to slide 4 here, actually, let me slide 4 and example C. I got a couple mistakes I made here when I gave you this note sheet, so let's fix that. The equation y equals kx transforms to, it should read y over x equals k, which means that the ratio of y to x is constant. And it says, again, it says if k over x, I meant y over x, is 3, then which pair of numbers does not fit the relationship? So real quick here, we've got y equals kx. We know that that's a direct proportion where k is the constant of proportionality. If I simply divide both sides of that equation by x to get k by itself, I'll get this. If I divide both sides of this equation by x, I'll get y over x equals k. And that's what I'm talking about up here. So we just transform that direct variation equation around. So in the question here on example C, they're saying if y over x is 3, then which pair of numbers does not fit the relationship? Well, the y value, 12, divided by the x value, 4, should equal 3. And in this case, 12 divided by 4 does equal 3. So A does fit. What about B? Does 18 divided by 6 equal 3? Yes, it does. So that one fits just fine. We're trying to find which one does not fit the relationship. What about C? Does 3 divided by 9 equal 3? No, it does not. Now, some people might look at that and think, well, 9 divided by 3 equals 3. That's true, but the equation is not x over y equals k. It's y over x equals k. So you got to do it in the right order. You can't just flip-flop orders. Which of the following is not an example of a proportional relationship? Let's see. Distance and time when driving at a constant speed. Well, let's make a little quick graph here. First of all, your distance is going to be 0 when you haven't traveled any time at all, so that works. And as your distance goes up, your time goes up. So that is an example. What about quantity and price when the unit remains the same? Well, if you don't buy anything, quantity and price, and if you don't buy any quantity of anything, it's not going to cost you anything. And as the quantity goes up, so does the price. So that is a proportional relationship. What about hours awake and hours asleep when the number of hours in a day remain the same? It seems very similar here, but when you think about it, the time you spend awake versus the time you spend asleep. Well, if you're awake 0 hours, you're not asleep 0 hours. You would be asleep 24 hours. So that doesn't work out. And you can see that that is not a, that is not a direct proportion or a proportional relationship. Again, if we're awake 0 hours, are we asleep 0 hours? No. We're asleep 24 hours, I guess. All right, so it's not a direct proportion. Which graph below shows a proportional relationship? I think you guys could look at this pretty easily and see that A is a proportional relationship. It's a straight line that goes through the origin. Yes, B is a straight line, but it doesn't go through the origin. C is not even a straight line. Forget about it. So, and this is that kind of idea of time versus distance traveled. Which equation is an example of a proportional relationship? Well, again, it should fit the model y equals k times x. And this one does. And 30 would be the constant of proportionality in this case. The other two do not. You're not going to see any exponents in a direct proportion, and you're not going to see 3 variables in a direct proportion. All right. That's all I've got for today. Hope you enjoyed the lesson because you've seen it all before and it should just be a big review for you. So we'll come in and we'll practice some more tomorrow. We'll see you then. Bye.